So we're in the Magnetic Resonance Center, and while I have Dr. Cherry here, I'd like to discuss some kind of good and bad habits as far as actually making the sample that we're going to put into the automated NMR. Because I think this oftentimes controls whether you get good or bad NMR, spectral data. A lot of it starts with, do you have a good or a bad sample prepped to put into a nuclear magnetic resonance instrument to even collect good data from. So while I have you here, we have kind of a standard sample rack that has 5mm NMR tubes with a bunch of people's samples. And so I'd like to use this as a way that we could kind of look at some of these samples and talk with Dr. Cherry about, what are some potentially good and bad habits to get into when making samples. So with that in mind, let's just start with the NMR tube in general, which is you've been using mainly Norel tubes, right, lately? Okay. And specifically some of these new secure lock tubes because they don't evaporate solvent very well. They also have, a lot of them have kind of an area in the middle where it really it's scored in such a way that it grips onto the turbines a little better. So starting with good NMR tubes really does make for a good sample, right? Right. And so do you have any kind of good and bad habits about picking NMR tubes, ordering them, etc.? Any companies that you prefer?
No, once you have purpose-designed NMR tubes that generally takes care of most things. Most problems that occur with NMR tubes are overuse of them, and heating them in ovens to dry them, for example, can warp them, and so you want to make sure your tubes are always round. A good rule of thumb is if you take an empty NMR tube and roll it on your desk, if it wobbles, throw it away and get a new one. It's not worth it. It's going to break samples and cause damage to the instrument. So that's the main thing with those.
And I think, for people to realize 5mm is probably the most common liquid state size, and they're meant to emulate kind of an infinite cylinder. But they are fairly precise as far as how straight they are, how cylinder-like they are, and they're very thin-walled, right? So you also have to be fairly careful when handling these because they're not really thick-walled glass.
Correct.
Okay. So then let's look at a couple samples. Like, for example, this first one I pull, the first thing I get the indication of is not enough sample. Right?
Correct. Well, let's be specific. There's not enough solvent in this sample that we can't make a determination whether there's enough sample of a compound of interest in it or not. But when the sample is this short of solvent, that interface between the air and the liquid is a susceptibility difference, and that causes major magnetic field distortions, which distorts our NMR signals and obscures any information you want to learn.
So the height that you need, the total amount of solvent plus your sample depends on the NMR, does it not? But what's a general rule of thumb? Like for most modern NMR spectrometers, what is a general, height that you should use?
Approximately 40 millimeters.
Okay.
So that equates to 0.5 milliliter or 650 microliters, depending on the vendor, of solvent that you want in a 5mm tube to fill.
But to know precisely is typically when you need, the depth gauge for the instrument you're using.
That's part of it. Also with either the manager or the manufacturer of the instrument will tell you this is the height for that probe, and then you will create your own gauge that has a level filled to this height. A rule of thumb has always been the 3-finger rule. So when you come to your hand, you use your 3 fingers and fill it to that height, and you probably are okay.
Okay. What is the disadvantage of having too much liquid total volume in your NMR tube?
So if you're doing a routine proton spectrum only, that disadvantage is purely sensitivity. You just over-diluted your sample and caused that problem. If you're trying to do more multi-dimensional experiments that use gradients and other things like that, you've now introduced artifacts of the signals from your samples that are at the top of your tube are not experiencing the same radio frequency pulses as they are in the middle, and so you get distortions, especially refocusing gradient pulses have other problems. So there's some artifacts that occur with too big of a sample.
So really, it's more acute problems on the small side, but even, having too much solvent can really cause some major distortions in there. And so when you get the volume about to the correct level, about 3 fingers, which this one is about perfectly, right? Then, and you basically have a sample where everything is dissolved within the solvent, then this is kind of the ideal sample that we're looking for. Is that correct?
Right. That's the next step, is to make sure there's no particulate matter inside there.
So what you're worried about is, for example, say a sample like this, where clearly, there's a brownish liquid here, but there are clearly what I would say precipitate or solid at the bottom. And so is this something we can put in the NMR and run, or is this something
you can always put in the NMR and run, whether you're going to interpret it. In a case like this, where all of that sample has gone to the bottom, that probably is what you want to look at. So now your effective concentration is very low. Another problem is when that solid is actually still dispersed across uniformly throughout the sample. You think it looks good, but no. That interface between the solid particulate and the liquid itself is just as bad as the interface between the nixus and the air. You'll never be able to shim that sample to get high resolution data. So in that case, when we have situations like this, one, choose a different solvent that your sample is better at. If you can't do that, run your sample as it's dissolved through some glass wool or something to filter away all that particulate matter so that you have a perfectly homogeneous sample before you put it into the instrument.
Okay, and this looks like an even more acute case of just that one where, in my opinion, it looks like what has happened is they used to have a lot of solvent in here and they've let it evaporate over time.
Right.
And so is this something you could imagine salvaging this by adding more of the same deuterated solvent into it, and if it all dissolved, being able to run again? Yes. Or is that something that's not?
Yeah, as long as nothing else occurred other than this is now a super concentrated sample, then you can recover that. But in most cases, you should prep clean. Depends on other things that have happened.
Okay, and then to actually go back to the one here, so say we, like you said, we could put this in the NMR and run it, so it has enough height that it would be proper. What would, putting this in the NMR, what you're saying is the main thing I would look for is peaks that are distorted, broader, not symmetric, et cetera, is what you would expect you would see because of the magnetic susceptibility differences as you go from the precipitate up through it? Yeah,
potentially, but also your main thing is that if the precipitate is exactly the molecule here and there's no other reactions that occurred in this sample, your total signal is going to be dramatically reduced because 95% of your sample is now solid at the bottom, which is invisible or distorting in the field.
Okay. Are there any other, major ones that aren't kind of shown in this kind of sample lot that are major problems that students run into when they're doing this?
Yeah, a couple of them are things where they don't put the cap on straight, so it's lopped off to one side. Or if you case here, this is a good example of having a nice label that's taped on. You can't have things that have flaps or little flags because we're going to take these samples and actually rotate them in a circle. So they need.
So that's what this component is for in it, right?
Physically spinning the sample.
Physically spin it, and that's to measure the speed of it. So almost all your NMR tubes go into these type of turbine or rotors, right?
Right.
And so if there's something sticking out, it'll cause a distortion in how it spins?
Right. So you can't have anything sticking out around the tube. You can write on them or you can tape something on that's secure.
Okay. Well, I really appreciate you going through some of this because I think we see it a lot in NMR that it's not the NMR that's not working properly. It's oftentimes the sample that's not prepared in a way that you could collect good NMR data. So thank you for taking the time.
Can I make some more rule of thumbs that we should at this moment? When you come and you have samples, you either have an oil, which is a liquid, or you have a fine powder as a solid, and then you're going to dissolve that into a suitable solvent. But a question I get a lot is, how much stuff should I put in there? And as a synthetic chemist, you run reactions you may not know exactly, but you really should for NMR. And a good typical rule of thumb for a well-behaved organic solid is if you have a milligram of material per unique carbon in the expected molecule you have, you'll get high quality data, can do all 1- and 2-dimensional small molecule structure things from that kind of sample. So you really need to think about that. And of course, then what does that mean in terms of concentration? Well, it depends on your formula weight. How big of a molecule is it? If you had a milligram of a very small 100 Dalton molecule, well, you can get really good NMR because your concentration is very high. But if that molecule you put in there is 2 kilodalton, now you have thousands of unique carbons. Your signals are diluted over that for each individual signal. You might have a tough time solving its full structure. So you may work at a higher concentration.
Okay, so say we do have, this is probably, on the order of several milligrams of sample, put at the bottom of an NMR tube, right? So, and this is of an organic solid material. And like you said, your almost always starting point is a solid organic material of some sort, or like you said, an oil or a liquid of some sort, where this is a fair amount, right?
Right.
This is 100 microliters or more. So now, the recommended way of putting deuterated solvent in here, I always recommend that students use sealed ampules for this, because it kind of gives you, a lot of times you can get those sealed ampules at half a milliliter, 0.7 milliliters, so that you can put all of it in at once. You don't have to worry about contaminating a bottle, et cetera. Do you have any other recommendations as far as when you're going to add solvent to this?
The other one is if you buy bulk solvents, to take that bulk solvent container, portion out the small you're going to work with, and keep the main stuff separate, so that you have less contamination of your solvent. And then whenever in doubt, if you're worried there's peaks that you don't explain, one of the good things to do as a synthetic chemist is to take that bulk solvent container and just simply run an NMR of it alone and find out if there's any contamination in your solvents itself if you're not using sealed ampules.
Okay. Well, I think that gives us a good handle on some do's and don'ts for making NMR samples and having them ready to run NMR on. Thank you.